Okay, it looks like we're live. So welcome back. Today I'm going to be actually doing something a little different. I'm going to be implementing a hash map. So this is something I've been wanting to do for some time now. I've talked about it on stream a bit. For my virtual machine, I've used a hash map a couple times, and I've just used I actually use this one. I can provide a link for that hashmap.h. This one right here. This is actually the code for it. Yeah. Let me go back. There we go. This one is the one that I've been using. And it's a nice one. It works well. But I would like my own, essentially. So that is what I'm planning on working on today. So, I wanted to start working on in Go an IRC client for my Twitch bot, like a custom one. But I need to do a bit more research for that first. So the next couple days, I'm going to be doing different kinds of streams, and then I'll get to that once I'm ready. Yeah, so let me just get started here. Let's make a build.sh. Yeah, so we'll use claim. Sure, why not? And then just do that. All the warnings. Okay, so let's go ahead and do that. And I will just include, I'll make a simple hello world really quickly. Hello world. I have been coding Go a bit, so forgive me if I miss some semicolons. Alright, so let me just run that and run the file. Okay, so that looks good. It looks like it's all working. So basically, the way a hash map works is it's basically an array. So in an array, just imagine this is an array. You can have different elements, and they all have an index, right? So this is the 0th index, then the first, then the second, then the third, right? And basically, that just points to a location in memory. So the start of the array is a pointer. And then you just add to that based on the index. Yeah, so you just add 0 to get the first index, add 1, and that is, it is a constant time operation, O of 1, if you are into data structures and algorithms. Okay, so, that's basically how that works. But the problem is, it's hard to sort of store this as a value to know where it's at. So, you might have to traverse the entire array to figure it out. But if you could use an identifier, for example, a string, so like for, yeah, this is a bad example, but you get the idea. Basically, use a string, which basically points to it. So you can do 3, and that points to the index here. That would be quite useful. So that is basically how a hash map works. So you need a hash function for that. Wow, Ryan Gosling just followed. Thank you, I appreciate that. Big fan of yours, big fan. Yeah. Okay, so, that's basically what I am going to be doing. So, we need a hash function for that. So, right now, I'm just going to use a random one, and then I'll implement an actual, like, well-known, established one in the future. So this can just be the hash, yeah, I'll just call it hash. So that is what we're doing, basically. And what we're going to do is take a string. So basically, I want this to be fairly general purpose, but one constraint I'm going to have is that the key has to be a string, and I think that is reasonable. So yeah, this is just the key, essentially. Yeah, so then we will just have a hash, so it'll be an integer. So it'll start at 0, and then for this, we'll just iterate throughout the entire length of the string. What's this language? It is C. C programming language. Pretty popular one. It's kind of like the grandfather, if you will, of nearly every modern programming language. Yeah. So key, basically for the length of it, we will iterate through it, and then the hash, we'll just for now, just gonna add, and then I'll do something like maybe, let's see. So the current index, key I, and we will use the integer representation of that, like that. And so we'll just like multiply it by 10 or whatever, divide by 3, something like that. So that'll be good enough for right now. It's not necessarily a great hash function, but it will get the job done. So yeah, semicolon there. And then we can just print out the value of that. And maybe this will be a size t actually, because it cannot be negative. Yeah, so size t, there we go. Yeah, because it's unsigned. So, alright, so then we can just print out the hash of just something, so like a word, for example. And if I did it all correctly, I did not. I need to include string.h. String.h. There we go. And let's see what else. Person of integers. Alright, so yeah, this can be a size t as well. That is all good. And all right, and let's see what happens. So 1479. All right, so that would be the index in an array. Essentially, is how that would work. So you can do something else. We change it to words. It's going to be something different. We need to recompile it. There we go. That, or you can do 2. And there we go. It's a different number. Not necessarily every time. You will have some collisions, which is something that we'll work on in the future. But the problem is that's a pretty big number, and our hash map or our array might not necessarily be that size. So we can just define a hash map size, for example. So yeah, maybe we'll do 10 for now for testing, and then we can just do mod hash map size. So that's going to constrain it, so it's never greater than 10. So if I run this, now it's 2. So it's not going to be different every time. Yeah, there is going to be quite a few collisions, which we will deal with. So it still is different though. Now let's actually define the struct of the hash map. So this can be the map. All right, so there's a few different things that we're going to need. So we will need a value. And then we'll put the key in there as well. Yeah, so that should be good. So actually this needs to be an array of hash map size. So this is really the map. There we go. So then the values will be stored in here. So yeah, basically we can initialize one right here. So we can do map, and we will just allocate that. Size of map. All right, something like that. And then in here we can actually hash something and place that as the index in the map. So this is the size of the map. Okay. So we'll just place something in the index. So if we do map.hashmap and then hash of something, so word for example, equals 5. So it's an integer right now. I will change that. And then if we actually print the location of that, like that, then if I did it all right, I did not. Size t. But this is an int. Yeah, so that needs to be an integer actually. Not a problem. All right, map is a pointer. Yep, I need to actually use that. Thank you, C. All right, and let's see. And then we need stdlib. Okay, and now let's build it and run it, and we get 5. So that is actually stored in there. So we can do that as many times as we want, and it will be the same thing. Please show how we convert the key. Sorry for the language, I'm speaking Russian. The convert after the key. Let me see. So, oh, you want to see the hash representation. So like, no, we just need hash of word, you mean? Something like that. I forgot a semicolon, my bad. There we go. Something like that. Is that what you mean? So that's the position in the array. Yeah, that is what it corresponds to essentially. But we can also change it, so we can make it 2, and then word is actually going to be empty. So it's just 0. So if we put 2 here, it actually is 2. And then if we change one of these to 2, it will actually show the value of that. Yeah, so that is kind of how that works. So we'll want some functions to work with it rather than that. So we can make something to initialize the hash map, perhaps. This can just be init map, essentially. And this will just take a pointer to a map. Something like that. And then we'll iterate through equals 0, and then while it is less than hash map size, we'll iterate it. And then, yeah, so we will just set it by default to null. So let's see, hash map, whoops, it is map, all right, if I can type, hash map, I, and we'll just set it to 0, something like that. And then, yeah, so that should initialize it. So we can do that, and then we can do, init map, and that should work fine. And yeah, okay, so now we don't actually place anything in it. So let's make a function to place in the map. So this will return probably an integer for the exit code. So this is put in map, essentially. So we'll take a pointer to it once again, and then we also need the value that we're going to put in there. So int value. So it has to be an integer right now. Again, I'm going to change that and use a void pointer. But for now, we don't have to worry about that. So we can just place in it like this. We actually need the key as well. I forgot about that. Let's write a calculator later. Yeah, I could write a calculator sometime. Okay, yeah, we need the key as well, which is that. Alright, so then we will do the hash. It's actually going to be a size key. Hash equals hash of the key. And then we'll get the hash, and then we use that as the index in the array. So, map, hash map, and then the hash equals that. And there we go. So that is all that we have to do. So then we can return 0 exit code, and let's see. So, we need some way to see if it fails. Let's see. So if, I guess we could just check if, map hash does not equal 0. And I forgot actually some of these. Alright, there we go. If it's not 0, that means something's already there. So from now, we'll throw a value for that. Or we will just return 1. Yeah. So I think in the future, it's going to be a little different than that. But basically, that means it's not empty. So we will do that. Yeah. So I think that'll be fine. And then we can put in map. Okay, there we go. If I can type. And we'll pass the map. The key, so yeah, we'll pass 2 again. Yeah, and then we'll pass the value, so 15, for example. And then when I run this, let's see, I messed something up. It's not a function or a function pointer. Okay. I don't know what that. Hang on. Let's see. Oh, because wait, no. Actually, is this a built-in function? Can I not call it hash? I don't understand exactly. I'm missing something right now. Let's see. So hash equals the hash, the key. That should be fine. Huh. Oh, because we can't. Okay, we can't call it the same thing. So this can just be the index. Sure, that's fine. Yeah, that was a little stupid, but okay. Index. There we go. And now, all right, so we can run that. And there we go. Place it in the map, the 15, and we can change it to whatever we want. We can put as many in as we want. So we can put 2, word, and hello. So we'll put 25, and then 35. And then this one will be word, and this one will finish to hello. And then, let's see, there might be collision, actually. Alright, we did get a collision, it looks like. So, let me print the hash of hello. And it's probably 9. Ooh, it's 2. Okay, yeah. So it's 2. So it's actually the same as the 2. So that means we have a collision. So that is something that we do need to work on. Because if you have a collision, then it just replaces the value. And that is obviously no bueno. Actually, we don't check if... yeah, so we don't actually replace the value. We just return 1. So we didn't actually check if put in map does not equal 0, then we will just print an error. Error already, slot already filled. So yeah, we'll just do something like that, and then exit with 1. Sure, so we're going to actually trigger this error. So let me do that for the rest of them as well. So yeah, this one, we have word, 16, it doesn't really matter. And then this one was hello, which was the collision. Alright, so if we run this, now we're going to get the error. Slot already filled. Yeah. Obviously, that's not a super useful error message, but you get the point. So, that is something that we need to work on. First, I'll add stuff, a few more functions, and then we will add that. Alright, so let's make a function. Let me actually get rid of the collision one, and then leave it at. Okay, so we'll just print those out. And then, let me make one to remove something from the hash map. So, int remove from map, and yeah, we will take a map, the key, yeah, just the key. So that is all that we need for that. So, we'll basically, we'll go to the index, and then we'll check, if it is 0. Yeah, I'll just do it, and then I will show you. So, index equals hash of key. So, same thing that we did up there. Then we get the key. And then we want to do this, but actually the reverse. I actually do want to do the reverse. If it equals 0, then we'll return 1, because it's already empty. Even though you could put 0 in here, but we'll get to that. We will get to that. Otherwise, we want to basically remove it from the, set it to 0. So we can just do map, hash map, index equals 0. And then return 0. There we go. So then we can remove from that. So if remove from that, and then yeah, we'll remove word. Does not equal 0, then we'll print an error like this. Let's see. So then, not already empty is in this case empty. It's not already empty. Yeah. So now when we print this out, it should print 0 for word. Yeah, print 0. So we actually removed it from the hash. So, yeah, that's pretty good. And now, what other functions would we need? Well, we would probably want something to iterate over all the keys. So you could, let's see. You can iterate over the keys, and then list each index in there, or each key, rather. Yeah, but we don't need that now. For now, I think what would be a good idea is to actually work on collisions. Because when we collide, we throw an error. Instead, we could use a linked list. So if we make another structure of just a node, and then this has a node next, and I think we need to throw a structure in there. And then it can also have a key and a value. And actually, the key is not going to be, it's going to be a character. And then, instead of being an array of integers, we can have it be an array of node, like that. And then, let's see. Actually, it can just be, yeah, an array of nodes. And then each node, you can go to it, and then you go to the next until the key is the same. Yeah, basically, I can show how that works. So, I think I did all this, right? So then, we're not just using integers, so it does work a little different. So, we can initialize the map. We can just set it to null, like that. Each thing will be null. And then I think we can also do map hashmap I.next, or let's see, I.next equals null as well. So then they're both null initialized. Okay, so that's the initializing. And then when we place it in the map, we actually have to place the dot value equal to value. And then we want to place the dot key equal to the key as well. And that is important because if you're going through, I can actually draw this to illustrate basically what I mean. So if you are, you're going through. So imagine this is the array, and then here is each of the nodes in each slot, right? And then you can have another node up here. I'm not very good at drawing, and I just have a mouse, so apologize for that. But these are the nodes, and they connect like that. So say this is the first one, and it has 1, and this has 3, and then you have another one in here that has 4 and 2, and say these keys are the same, right? So they collide, so that is why the 2 goes there. If you go here, you can actually compare the key to this, and if it's the same, then you know that you have the right one. If it's not the same, you have to go to the next one. That is essentially what we have to do. So we need to compare each key when you put it in the map. So we do need to check, it does not equal null. Then we want to go until it does equal null. So while map hashmap index, let's see, while it is not null, so we don't need to return 1. Then we just need to do, yeah, maybe we should make a node here. So let's initialize a new node. Syntax of the language is similar to C++ a bit. Yeah, well, it is actually, so C came out in the 70s, and then C++ actually came out, I think it was sometime in the 80s, and it was meant originally to be just C but extended, so with like classes and stuff like that. So basically every C program is supposed to run in C++. That doesn't necessarily happen anymore, but that was the original idea. So it is actually derived from C++ derives it from C. So that is why they're very similar. Okay. So we're going to want to initialize a node here. Node current equals map hashmap index. Yeah, so that is the current node. And then while the current does not equal null, then we will go ahead and do this. Yeah, then we'll do current equals current next. So it'll be set to the next one until it gets to a null one. So we need to actually change this to current as well. Current, whoops, current. There we go. My E key is kind of dying. Okay, so that should mean that it becomes null. So we know that it is null. Then we set the value in the key. So this needs to actually be current. current, and current. Okay, current. Perfect. There we go. So that should be good. So that should set the value in the key, but we do need to actually allocate space for this. Yeah, so this, then after that we can do, let's see, current equals malloc size of node. And this current, there we go. And so let me actually place this here, node current, and then this can just be current equals that. So we'll move it to there, and it should be allocated then. And we do actually need to allocate space for the key as well. So current.key equals malloc size of character times the string length of the key. So then that way that can actually stay in memory. Because we do need to keep that. So then we'll need another function to free all of this so that we don't have anything left over. But yeah, that should be good. For now, we don't need to allocate the key. Yeah, that should be fine. Alright, so let me actually build that. And we do have some errors. Argument has type node. Okay, so we do have errors there. Let me actually finish. I don't know why I built it. I need to finish this. So now the remove from map equals null. Then yeah, it's already removed, so that is good. And then hashmap index. Yeah, basically, it's a pity that there's not much programming training in Russian. There's, especially C. I did not know that that there's not, because I'm pretty sure there's quite a few Russian programmers, but I guess not many of them actually teach in their language, I suppose. Yeah, sorry to hear that. So we can do that. Basically, if it equals null already, we want to return 1. Otherwise, we need to actually check the key. So if map hashmap index dot key is actually the same as the key, so we need to use string compare. Key equals 0. Then we want to actually set it equal to null. Otherwise, we're going to go to the next one. So we will actually, let's make a node current equals hashmap index. There we go. So that is the current one. And then here we can actually check if current already equals null. There we go. And this can be current.key. Current.key, and then current equals null. Yeah. So that should be fine, I think. Otherwise, we want to actually go, let's see. So if it equals 0, wall string compare of current.key and key not equal 0, then we want to basically go current equals current next. There we go. Because then we'll go to the next, and then if we get to the end, yeah, actually, so then we can do if current equals null, then we will return 1. So then that should be good. And then once it equals that, so at the end, if we get to the end, then we'll just do current equals null. And that should be good. And then we can return 0, and it should all be good. That should work, I believe. So let me actually compile this, and then we do have some errors. So let's go to the top. Let's see. All right. Node is reference to a point. All right, so that I need to do. That is 31. Let's see. So right here, this needs to be next. Okay, a couple more. Let's see. Right, that is again. So that's all good. 37. Expected that. Okay, missing a semicolon. Okay, incompatible pointer types. Okay. So it cannot be. Ooh, okay. So I forget how to deal with this. I think you have to do something like node in there, and then get rid of that. Something like that. Let me work through these. Okay, so let's do. Let me just. We don't actually have something to get from map. That is quite important. Yeah. Dot. There we go. Actually, get rid of those. Needs to be like that. Okay. There we go. Okay. Did you mean to use that? Yes, I did. Okay. Current key. Okay. I probably do that up here as well. Maybe not. Okay. Actually, I did it again down here. Right here. There we go. Get rid of that. There we go. And then, I need to use that. Yes, I did. Okay, this needs to all be that. There we go. Whoops, and I just quit out of the file. That is no good. Let me rebuild it all. You must use struct tab to refer to type node. Okay. Then it doesn't like that. Okay, so I guess that works. So let's run main and we segfault. So it didn't work, but that is okay. So let's try to see where it stopped from. So let's not remove from that. Let's see if that is the issue. Run it, and we still segfault. Okay, so let's just place one in the map, and that is probably where it is failing. Yes, indeed. So let's figure out where it's at. So here we have the put in map. So I'm pretty sure that should work. Okay, current equals that. So let's see if we actually get past here. So print f here, and let's see if we get there. We do not. So it is somewhere there. I'm assuming it is right here, but or right after this, right? It is not. Okay, so it was before that. It's actually setting that. No. Okay. Alright, so maybe it is actually in the init map function. That would make sense. So in the init map, okay. Actually, do we initialize it? We do. Alright, so that is probably where it is failing. So I can actually make sure it is by at the top. Yeah. Alright, so when we go through. Alright, so does it fail with this? Do we get past one of those? We do. Do we get past that? Maybe I need to do hashmap size -1. No, alright, so it is with this one. So we can't set the next equal to null. Because there is not a next, I suppose. Hashmap I, okay. Alright, what if? Alright, yeah, so it doesn't like that. So let me just not do that. And it should still be fine, because we don't actually rely on that. Then we still segfault. And that is probably in the place function now, right? And it is. Okay, so we're making it farther. So I'm assuming it is in there. In there. Let's see. Okay, right there. Did we make it past here? Oh, we do. Okay. So it is somewhere setting this. So we need to actually set the next. Current next equals null. So I don't know that it fixes the issue. It's not seem to. So let's see. I'm assuming we don't make it there. We do not. So it is one of these. One of these. Is it setting the value actually? It is. Okay, so we can't set current value. Okay. Current. Okay. Okay, because we never actually set the next. So let's see. Okay. So we want to set current next. Okay. Yeah. Okay, because current is actually null. So that is why it does not work. But we don't want it to be null anymore. So let's do let me do this. That index equals current. Alright, yes, that doesn't fix it. What if, okay, set current equal to that. Let's actually allocate it afterward. Then right here, okay, get rid of that. So we allocate that. And then it doesn't fail. But we need to, we don't actually point to this anywhere because, yeah, basically we want to do while current, next, it's not equal, no, current equals current next. There we go, I missed that E. Okay, so we want to do that, and then we want to basically do, current next, yeah. Actually, let's make like a 10. So node 10 equals current, and then we go through this, and we'll do this with the temporary one. Temp equals temp next, and then we want to set temp temp next equal to current. And then now we have the current in there. So we can use that. That should be fine. Okay, and then that should point to it properly. There might be some logical errors in there, but it should be fine. And let's see. So can I do that? Alright, so now let's make something to get it from the map. So get from map. Alright, so we need the map and the key. And the key. Okay. So, basically, we want to get the index. My E key is dead. Is it completely dead? Okay, there we go. I see index equals hash of key. There we go. And then, let's see. So we want to basically return whatever the value is at the index. So, if, let's see, if map hashmap index equals null, then we want to return 1. Otherwise, we want to actually string compare. Do a string compare. If strcomp of map hashmap index dot key is the same as key, then we want to just return that index dot value. Else, we basically want to go while it is not while strcomp of current dot key, and key is not equals 0. Then we want to do current equals current next. So we need to actually make a current. So node current equals map hashmap index. There we go. So then we'll go through the next until it is the same. And then we can just check if current equals null. Then we want to actually return 1 as well. Otherwise, that should be fine. And then we want to just at the end return current.key. There we go. All right, so let me see if that will compile. And it does not. Okay. Yeah, we want to actually return current dot value. That is what I meant. Okay. All right, and that is a pointer actually, so I need to do that and this as well. And let's see, right here, I think 2. Okay, there we go. Build that, and if I run it, we get that still. I can get rid of that. And then let's just try to print. Okay. Yeah, just the value that we get here. So get from map, map to, and there we go. And let's see what that prints. So it might not work. We get 1. So that is not right. So it actually returned. All right, so it didn't work. So let's just do int value equals get from map, and 2. There we go. And then if, whoops, there we go. If value does not equal 0, then I will just print an error. Key not in map. There we go. Otherwise, we want to print out the value. So we are going to get an error actually. I know this. Know this for sure. Alright, so build that and run it, and key is not in map. So why is it not in map? So there is clearly an error somewhere either in placing from map or getting it from map. So let's see if this is where we return. And that is okay. So we actually have an error placing it in the map. So current is that. And let's actually do equals map index. There we go. Okay. So then otherwise we can do that. And then let's actually set temp right here. So we don't have current. Temp does not equal null. Okay. Else temp equals current. Right, something like that I think will work. Maybe, perhaps. Current is not defined because we don't actually define it. So alright, initialize the variable current to silence this warning. Okay, yeah, so let me just size of node, there we go. Just get rid of that. So run this now, and it still doesn't work. So in here, maybe I can just do this. Get rid of that. Place it here. So then it'll be pointing to the next one. So that is wasted space though. That's not exactly what I want. All right, let me actually go back. Else want to do map hashmap index equals current. There we go. Yeah, so that should be setting it. But it is not. So let me printf what the key is here. It is key, and let me actually do current key. There we go. And let's see what we get from that. So key is none. Ooh. Oh yeah, because we don't actually set it yet. All right, so we do that. Key is 2, so that is right. Okay. All right, so that's not. That is not what we need to do. So key next equals null. So, why does that not place? Alright, perhaps we could actually initialize all this before we do that. So, if I take this and do it up here, and then we do all that. So, yeah, it still doesn't work. Key not in map. So, when we get from the map, is it still here? Let's see, is that where it fails? It is not, so we do get farther than that thing. Alright, so we get here. And so we don't get here, I assume. We do. So, oh, you know what? I know what it is. We can't just return that. So we need to actually, yeah, I know what to do. So we need to pass a pointer into there. So we can make value. Just like that, actually. And then we want to do in air equals that. And then there we go. Get from map. Map to, and then we want to actually pass that. So let me make it not a pointer, and then we'll pass the pointer to it, and then we'll basically set the value equal to that. So that is actually what we need to do. So, yeah. So then in here we need to actually pass a pointer to the value that you want, and then we'll set. We'll do value equals map hashmap index value, and we will return 0, and then here, return 1, we want to return 0, and then we want to do the same thing that we did there. So, value equals current value. There we go. So now, 15. Alright, so we actually got the value. And I can change this to 18, and it'll be 18. And we can actually change the key to be something else. And, key is not in the map. So yeah, that is actually perfect. But if we put it in the map, something like this. Word. Let's put 21. Sure. Run this. Actually, no, I need to change this. So word. Run this, and then we get 21. Perfect. Yes, that is actually good. And if we do 2, we should still get that, unless there is a collision. Okay, and let's actually try something that will collide. So I think we need to figure out a hash that is actually the same. So I had something earlier, but I don't remember what it was. I think it was hello, actually. Hello. So let me try to get hello. See what happens. So it should be 21. And it is. And let me try to get 2. And 18. Okay, so let me print the hash of both of them. So we'll just do hash of 2. And then hash of word. And I think that they are the same. Oh, this needs to be, my bad. Forgot the percent sign. Or the, yeah, percent sign. So let me run that now. And are they the same? They are not the same. Okay. Is it actually, let's see. No, hang on. It's 2 and hello. That is what I wanted to do. So if I run that, then 2 and 2. So they are the same, and it does get different values. So that is actually pretty cool. Yeah, so I can do the same thing here. Down there. And use a different one, so hello, and they are the same value, the same key, but it actually goes to the next one in the list. Yeah, and then it works. I'll do that, and then print the value. We print both of them. Yeah, so I don't need to redefine it. There we go. Alright, now if I run it, it prints both of them, even though they have the same value. So we should be able to do that as many times as we want. So if I change this to B1, the hash map size B1, then it will always be a collision. Yeah, so 0, 0, or actually, yeah, it might not always, because there's a 0. But I can't set the size to 0. So, or no, it won't be, because 0 is the 1. Yeah, that was just brain fart. Yeah, so we should be able to put in map as many times as we want, and it should all still work. So this is a little weird, having to do all this error handling, but I don't feel like separating it out right now. So if I do that, and let's not check for error, let's just get rid of that, and then just get from map each time. So print f value, and then value again, and I will just get from map. So let's see, what? Let me change this. So I'll just do something, and then world. Sure. World. There we go. Something in world. So if I do something here, and then world, and then world. There we go. And then also I'll do something that doesn't exist. So just anything. And print it out, and we'll get an error actually. All right. So yeah, we segfault. But, 23 and 23, because I put them to the same thing. So if I change it, they should all be different. Even though they are all sharing the index. So basically at this point, it's just a linked list, which isn't necessarily ideal. But if you make it like the size to be something like 1024, there's going to be very few collisions. So none of those are probably the same. We print out. Okay. Does that actually collide? Anything and world. Let me actually try that. So let me do hash of world and hash of anything. There we go. Let me try that. Let me see. No, so they are different. So I don't know why it printed out 25. But, yeah, that value, okay. And it all works. Yeah, so I don't know what that's about. But I can just get rid of that. So there we go. So that is a hash map, basically. It's only for integers, but it does work. So probably a good way you want to clean it up is like, let me actually make sure the remove works. So let me actually do if remove from map something equals 0, then I will just print an error. Let's see. Plot is empty. Sure, something like that. And then when we try to print something, it should not work. Okay, so it still did work. So, let me actually do this error stuff here. There we go, grab that, after something, and see what it said. So, yeah, we don't get any error. So, the remove does not work. Yeah, trying to remove something, and it does not remove it. So, let's see why. Remove from map. We get that. So I think current equals null. We really want to do current next equals null. So let's see. So we're not returning here. So so we do get here. So we set the current equal to null, but that doesn't actually get rid of it. Okay. Let's do current e equals null. And current value as well. I want to actually free all of it. So let me actually free current, and then free current key. Yeah, so value can't be set to null. That's okay. Alright, so let's run that. And now, there we go. Now we segfault. So that is what I was expecting. Actually, it shouldn't be segfaulting because we're trying to get it from the map, and it should be checking that. So we actually segfault before that. Do we segfault in here though? Yeah, so we do. So maybe we don't need to actually set it to null when we're freeing it. Okay, so we do that. Yeah, because we need to free current key after that. There we go. Invalid pointer. Okay, let me get rid of that. So it should be gone. And it doesn't work. So what is invalid? Is it this one that's invalid? Okay, invalid pointer. Yeah, so it is. Current key is not a valid pointer. So why is that? Huh, because we allocate the space for it when we place it in the map. Key equals malloc. Yeah. So when we free the current key, why is that a problem? If I do that, why do we segfault? 21, then 23. So we're trying to get 23. But we should be returning an error. So I don't know why we're not. There is, and then I will just put the error. So let's see, what does that say? So we actually segfault trying to get it. So that is why we do not print the error. So in the get from map, there is an issue. Is it because the key still exists? Actually, that is probably why. So, yeah, let me actually. If I do that, whoops. Okay, actually, I need to use a different one. So let me just do this. So I know where we're at. Okay, so we do get in there, but not after that one. So that is not where it happened. It's not where it's happening. How about down here? So are we in there? Alright, so we're in there. So else, so the key is not that. Ooh. Huh. So why is the index not equal to null though? That is the question. Because it should be when we're setting it equal to null when we remove it. So, but we don't set it to null. Let's see, let me do that. Huh. I do that. Okay, there we go. That is, well, no, that's not quite what I wanted. Yeah, that's not good. No bueno. Because we're still getting it there. Even though we removed it. So that is not good. So I can't set it to null first. Where is that? Alright, right here. So I need to do that differently. Do it differently. Let's see. I want to free it. And then let's see, hashmap index equals map. Okay, key not a map. There we go. So that is better. So we do need to actually do the same thing here. Except we can't do it exactly the same as that. So current equals current dot next. Yeah, because we need to set current equal to that. So let's make like a temporary one. Yes, let me just do load temp equals equals map hash map index. There we go, and then we will string compare with temp. Temporary equals null. We can do this, and then temp equals temp next, and then we just want to do this. So free that. Free temp, and then temp equals null. That probably won't work though. So let me actually change this back to 1. Right, for testing purposes. So yeah, then we get an error. Ooh, that's not good. So it loops forever. So that's not what we want. So when I'm trying to remove it, it goes forever. It goes temp next. We should be returning 1 there. Okay. So why does it loops forever in here, I assume? Let's see. That is probably nope. Alright, so it's not actually in there. So trying to compare. It's when we get, let's see, so we place 21, and then here we are, yeah, it's when we're trying to remove it. It must be there. We don't get there. We don't get there either, so right, let's see, debug. Okay, so we're not in there either. You know what? It's when we're trying to print it. So we do actually make it in here. I was not, yeah, so we do make it in here. Yeah, so right here. But then it goes forever when we're trying to print it out. So it's not setting it to null properly. So Mhm. See, wall temp next. Temp next equals no. Do that. Then temp equals temp next. And then, let's do temp next here. And then we want to free temp next. And temp next equals no. Alright, and we segfault. But that is better. Okay, so. We're getting closer. So let's see. Temp next. Alright. So we're comparing that. If that is null, return 1. Otherwise, we go there. And then free that. Because this works fine. But we need to set that. Okay. Temp equals temp next. That should be fine. Free that. But then when we're trying to get the value, which is right here, get from map, it's not get past here. Which we can verify like that. Yeah, so we do not. So it is in the get from map. Because it's not setting it to null properly. Let's see. Okay. Alright, okay. I probably should implement a way to print the entire hash map so we can kind of see what's going on. That would probably be helpful. Next, there we go. Okay. So, we segfault. Why do we segfault? Because it works fine when there is not a collision. Yeah, we can set that equal to null. Okay. So we go through here. I'm just trying to think. Trying to think what to do exactly. Okay. Let me see. So segfault, that is up here where we segfault. Let me look at the get from map. So we get to string compare, and then we're in here. Current equals null, then do that. Then we exit out of it. So we don't get to here. Yeah, okay, so we get here. Do we get down to this point? We do not. So we just try to set it equal to the next forever. Yeah, and then we get to the end. So, okay. Okay, so, how can we set it properly? Alright, I think I'm going to take, just about a 3-minute break. And then I will come back and hopefully be able to solve the problem. So I will be right back. Okay, I am back. So let me close out of that. All right, so let's see if I can figure this out. So, let me get rid of the free and see what happens. Yes, we still segfault. So, we're not setting it equal to null proper. So, so while that does not equal the key, uh-huh. Let me change this back. Then temp equals null. So let me just do that. There we go. I'll run this, and then it works, but it doesn't actually work. Because we still print it out. So something, we stored 23, and we print out 23. So that is not quite right. So we need to fix that. Let's do next equals null as well. Okay, then it just completely breaks. So that's not quite right. Yeah, okay. So key. Okay. Yeah, so we can set the next, but we want this to be okay, and want to set it equal to that, but not the pointer to it. So okay. So let me actually at this point print that value is, and I just want to print the value at the node. So temp value. Let's see what it is. Whoops, and okay. So value is 21. So at this point, 21. Okay. So when we remove it, that is correct. So 21. And then we're setting the next equal to null, but that doesn't set it equal to null. So is it a problem with this logic actually? That works fine. And then here, okay, here, current equals that. Key, while it is not the key, then current equals current next. If it's null, then return 1. Maybe if current next. And okay, key not in map. That's good. That is good. And then let me get rid of that. Let me actually, let's see, free next. Because we do not want memory leaks. Okay, key not in map. And then, if I set it to something that is definitely not in the map as well, that works. And then if I don't do that anymore, then it should work fine. Okay, that's pretty good. But an issue that we have is if you try to remove something, like say, instead of trying to remove that, or we try to remove it after we place world in the map, we're just going to go to the next one, and then we're removing this one, and then we're not actually updating the pointer to that, so it won't actually work. Yeah, it just prints 21 because we get to the end. So what we need to do is set let's see. Basically, we need to check if temp next does not equal null, then we want to do we need like a temp2. Temp2 equals temp, and we want to do temp2 next equals temp next. So then that'll be set to that. Then we can get rid of that, and then we just want to say temp equal to temp2. That should be fine. Alright, if I build that, it still doesn't work, so that's not quite right. Temp next. Otherwise it doesn't matter. So, yeah, this should be updating the pointer, but it does not seem to be. So,